is ellipses. This is the one that was kind of oval shaped. If you go back to, I don't have the other notes here. If you have a cone, right, these are all conic sections that we're talking about. The ellipse is the one that kind of goes this way as a cross section. So you get this like oblong, ovally type shape. Okay, that's what an ellipse is. Ellipses have a focus, but they actually have two. We call them foci. So they're in a parabola, there was a focus, right? One focus. In an ellipse, there are two, which is why we pluralize it. You say it foci with like that S sound, okay, foci. They are set points that will always have the same relationship to the rest of the ellipse that we're working with. The cool thing about an ellipse is you can pick a point anywhere on the ellipse. So like this pink point that I picked right here, okay? And the sum of the distance to the foci will be the same, okay? So if I pick a point here, then call this, we'll say this is A and this is, no, I don't want to use A and B. That's going to confuse you. We're going to use A and B later. Let's not use A and B. We'll say this is C and this is D, okay? But then I pick a point over here and I find the distance to the foci. So this one is a different distance, E, and to this focus, F, okay? What it says is C plus D, so the sum of their distances should always be equal. So C plus D should equal E plus F, okay? That's how we come up with all the different points on an ellipse. Now, I'm not gonna ever ask you to do that. You're just gonna have to freehand an ellipse from kind of the more basic points of the ellipse. But that is the idea of how they come up with all of the different points that make up the ellipse, is the sum of their distance to the foci will always be the same, okay? Okay, so here's your new equation. And for today and tomorrow and the next day even, we're only gonna do centers of 0, 0. In 10.6, then we'll move some things around a little bit and you'll have an HK vertex instead, or a center instead. But for today and for the next few days, we're gonna focus on when the center of our ellipse is 0, 0, which is really quite nice. Here's the equation, okay? Write this down. It is gonna be x squared over a squared plus y squared over b squared equals 1. Okay, that's going to be the equation that we're working with. Something to maybe just note, because every answer will look very similar, this will never change. So x squared over something plus y squared over something equals 1 will be every equation that you write today. So it's always going to start like that. Our job is figure out what is our a squared and what is our b squared. Okay? Where have you seen a squared and b squared together before? There's two squareds when you're working with a circle.
All I remember is a squared plus b squared equals c squared.
That's the one I'm talking about, Pythagorean Theorem, right? A squared plus b squared equals c squared. You're going to see something today that looks very similar to the Pythagorean Theorem. It's not the Pythagorean Theorem, but hopefully it helps you remember what you're doing. Okay, so just know when you write the equation of an ellipse, if you want to, right off the bat, you can write that down every single time with what we're going to do today. Then you'll just have to figure those two missing numbers out. Okay? You're welcome. Okay, so there are two different types of ellipses, and you can kind of see it in the picture already. The first type of ellipse that we're going to look at, so look at these two pictures. What do you notice? One is wide, the other is tall. Okay, those are the two types of ellipses that we're going to work with. So let's focus just on the wide one for now. Okay, notice here's your center. Okay, this is called our vertex. The distance from the center to the vertex is your a value. Remember, we had an a value right here. Okay, so the distance from center to vertex is A. The distance from your center to, in this case, your co-vertex is your B. Okay, God bless you. And then the last thing is the center to your foci. That's a length of C. Sorry, my C kind of got cut off there in the notes. So you have these lengths of A, B, and C in every ellipse, okay? You also have what are called vertices and co-vertices. In this case, okay, we're going to talk about all the different pieces. Notice this is the wider version. So when our A value, so this length, is bigger than our B value, it's going to be a wider ellipse, right? Now, if it was the other way, the B value was bigger, now it would be a taller ellipse, okay? So our center, what did we say our center was going to be all day today? 0, 0. So our center of our ellipse, that's this point right here, that big blue point, okay? That is going to be 0, 0. Our vertices are going to be whatever is farthest from the center. So it's tempting to go, okay, well, we have points here and we have points here. Maybe our vertices are the ones on the y-axis. It's always the ones that are farthest from your center. Okay, so the ones that are farthest from your center are going to be your vertices. That means it's always going to be a length of A, right? This right here is a length of A. So plus or minus A units, and 0 are going to be your vertices. Negative A0, positive A0. So that's 2 points, right? If you want to write it as 2 separate points, you totally can. A0 and negative A0. I just like the positive minus or plus minus there. Okay, so the co-vertices, look at your picture. Can anyone tell me what our co-vertices are going to be then? Zero plus or minus your B value, right? So we went B units up to get to this top one. We went B units down to get to the bottom one. So our co-vertices will always be 0 plus or minus B, okay? And then we have 2 different axes. We have the major axis. So the major axis is the one that connects your vertices, okay? This is your major axis. If we think about the length of that major axis, I know this is a length of A, and this is a length of A, right? It's the same distance the other direction. So your major axis is going to be 2 times whatever that length of A is. Your minor axis then is going to be what? What is it? 2 times whatever your B length was, right? This was B units up and B units down, so double B, and you get the length of that minor axis. Okay, so that's if our ellipse is wider, the stretched wider one. Okay, but let's go the other way then. Now, if we look at this one's taller. Notice your A value is less than your B value now. So the A is narrower, the B is longer, okay? All the same pieces, what is our center going to be? Still 0, 0. Okay, you still have a center right here at 0, 0. So we said your vertices are always whatever is farthest away from the center. So right now, our vertices are these 2 points. Okay, well, our B is always the vertical and our A is always the horizontal. So what are the points of our vertices now? That would be 0 plus or minus B. So notice the vertices on the one are the co-vertices on the other. Okay, so you got to make sure you're paying attention to what direction it's going. So then this becomes the vertices from the first one becomes the co-vertices from this one. So plus or minus A, 0 will be our co-vertices then. What's the length of our major axis right now? And first of all, is our major axis going vertical or horizontal on this one? It's vertical, right? This is your major axis. So what is the length of that? That's 2B. Notice again, we just swapped. And then the minor axis is 2A. Any questions on that so far? You understand what all the pieces are? And this will make more sense as we start to put it into a formula and solve some things. But I want you to see where everything is first. Okay, your foci. Remember, foci were these 2 points on the first guy, those bluish points, and these two on the second one. What axis do they always fall on? Your major axis, okay? Wherever your vertices are, whether this way or this way, that's where your foci will be also. They will never be with the co-vertices, okay? They'll be with the vertices on the major axis. Okay. Okay, so something to note in this setup, your C value, just like we said with parabolas, your C value is still the distance from your center to your foci, okay? So this is your C, or this is your C, right? So C is here, C is here. So that doesn't change. Just like we said with parabolas, same thing for ellipses. Okay, now there's this relationship with our A's, our B's, and our C's. And we know the Pythagorean Theorem, right? A squared plus B squared equals C squared. This is very similar to that, but our C squared is not going to equal the sum of them anymore. It's going to equal the difference. And it's different depending on which one we're working with. I don't need you to memorize these formulas if you can remember a concept, okay? Here's the concept. It's always going to be the bigger minus the smaller, okay? So don't worry about if it's A squared minus B squared or B squared minus C squared. It's always the bigger one minus the smaller one. You will never get a negative number there, in other words, okay? So subtract the bigger minus the smaller, and you will get your C squared every time, okay? And that will make more sense as we do it. But just remember, if you can remember this, bigger minus smaller, you don't even have to worry about memorizing that formula. Okay, and then last thing, and then we'll try some of these so you can see what we do with them. The foci for these, very much like what we did before. On this guy, if you look at the picture, okay, your foci were a length of C to the left and a length of C to the right. So that's your X value, right? Plus or minus C, but still at 0 for your Y value. Where are the foci on the other one? Now it's 0 plus or minus C. Now we're going up and down. So X is not changing, 0, and then plus or minus C. How are we doing? It's a lot of stuff, right? I think once you apply it, you'll see it's not as terrible as it looks. Okay, so we're going to work out one of these problems. Can I move away from all this? Are we good? Okay. And if I were you, when you're doing this homework, maybe just have this in front of you. I feel like that's helpful just to see the pieces that you're working with here. Okay, so keep in mind, our original formula was x squared over a squared plus y squared over b squared equals 1, okay? We need to figure out what's A, what's B, so we can find C and find all of our pieces here, okay? So the first thing we're gonna look at, can anyone tell me the value of A?
3.
It's 3, right? This is A squared is 9. So if A squared is 9, we can just take the square root of that, and that means A is gonna be 3. Okay, what's the value of B? 5. This is your B squared, right? So B squared is 25. If we take the square root of that, B is 5. Okay, so now let's think about that. I'm actually going to plot this before we move any further, because I think it'll help you just to see your setup. So if A is 3 and B is 5, we said A is always going what direction? Is A going to go up, down, left, right? Where are we moving with our A? A is going to be the left and right, okay? If you look back here, right, this is your A. This is your A. So if A is 3, then on your graph, you can go 1, 2, 3, and 1, 2, 3. Okay, that's your A value. B being 5 means you're going to go up 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. So this, all right, that's your B value. Do you see your ellipse now? If you just kind of freehand that in an oval shape, your ellipse should look like that. Can you tell me which of these 4 points, so in mine it's purple and orange, which ones are the vertices? Purple or orange? The purple. Remember, it's always the ones farthest from your center. So these are my vertices, right? These are my co-vertices, okay? And again, if you don't like to do it from the graph, you don't have to do it from the graph. We said before, your vertices are 0 plus or minus your B value in this type of ellipse. So your vertices are going to be, I'm gonna make it purple, 0 plus or minus 5. Okay, those are your vertices. Where are your co-vertices? Yep, plus or minus 3, 0. Does that make sense so far, how we're coming up with all that? Okay. What's your major axis? 2 times 5, right? It's 2 times the length of your B value. In this case, 10. Okay, this is your major axis between your vertices. That's a length of 10, 5 and 5. What's your minor axis? 6, yeah, 2 times your A value, 2 times 3, or 6. Okay, so the last thing we have to figure out is where do our foci fall? And if you recall, we said c squared is always going to equal something squared minus something squared. Okay, those numbers are given to you. They're here, right? A squared and B squared are right up here. Are we going to go 9 minus 25 or 25 minus 9? 25 minus 9. Notice they're already squared here. You don't square those numbers. That is A squared and B squared. Now, if you want to think of them as 3 and 5, then you would square them, okay? But they've already been squared for us, so keep them squared and just use them that way. So this is going to be C squared equals 25 minus 9. Remember, bigger minus smaller. Okay? That means C squared is 16, and if we square root that, then our C value is 4. Okay, now let's think about what that means. Is my foci, are my foci going to be on the y-axis or on the x-axis? The y-axis. The foci always go with the vertices, okay? Maybe you want to make a little note of that. These will always be with your vertices. Okay, so if I need to go up 4, 1, 2, 3, 4, that's one of my foci. 1, 2, 3, 4, that's my other one. That means my foci are 0 plus or minus that C value. How'd you do with that? Jada. The vertices are always the one that's, yeah, farther from the center. So longer, if you want to think of it that way. Yeah. And then the co-vertices will be the ones that are closer in. It depends on the situation, right? So on this type, the one that's wider, then your major is 2A. But on this one, where it's taller, your major will be 2B. So major's the longer one, minor's the shorter one. Okay, we gotta keep moving. All right, so this one, example 2, very similar type of problem. I'm gonna move a little quicker through it because we're gonna run out of time if we don't keep moving here, because you've seen one, but now this one's gonna be the other one. Notice the difference, okay? Our a squared and our b squared was bigger on that one. Now a squared and b squared, it's the a squared that's bigger, okay? What is our value of a? Yeah, if a squared is 100, then our a value is 10. You're just taking the square root of 100, right? A squared is 100, so square root both sides, we get a is 10. What's your b value? B is 4. Okay. Now, keep in mind, a is 10. A is always to the left and right. So 10 is negative 10 and positive 10. Okay. So my vertices are going to be at plus or minus 10, 0. Okay. Where are my co-vertices going to be? It's going to be 0, right? And then plus or minus what number?
4.
Your 4, your b value. Okay, so you're going to go up 4 and down 4. And then that's going to give you your ellipse. So you can just draw that oval shape in. Ooh, that was terrible. Okay. What is your major axis? Is it the horizontal or the vertical? It's the horizontal. This is your major axis, right? How long is that? It's 20. It's double that 10, so it's 20, okay? What's the length of your minor axis? That's 8. Double your 4, so your minor axis is 8. Okay, so now the foci. C squared is going to equal the bigger minus the smaller. What's your bigger up here? 100, right? So it's a squared minus b squared. So 100 minus 16. So simplify that. You get c squared. This one's not quite as pretty. 100 minus 16 is 84. It's not a nice number to square root, right? So what you're going to do with this is you're going to put it into simplest radical form. I know, we love simplest radical form. I literally love simplest radical form, but I know it's not your favorite for some of you. What perfect square is 84 divisible by? Four times 21 will give us 84, right? So the square root of 4 is 2. So that means C is going to be 2 rad 21. Okay, now you just have to figure out where that goes. So for my foci, are those going to go on the x-axis or on the y-axis? The x-axis. They always go with your vertices, right? So 2 rad 21 is going to the left and to the right. So that's going to be plus or minus 2 rad 21, comma, 0. Okay. And when you plug that in, I think 2 rad 21 or the square root of 84 is 9 point something. So you're going to have a focus here and a focus here. They're going to be real close to your vertices on the graph or on the numbers. Okay. Okay. We're getting close. Let's hope we don't run out. Okay, so this says write the equation. So now they give you the information and you're going to come up with your equation. So let's just plot what we know here. it says you have a vertex at 0, 5. So 0, 1, 2, 3, 4, 5 is a vertex. You have a co-vertex at 2, 0. Okay, well, that means we also have a vertex the opposite direction. So 0, negative 5, and negative 2, 0, because our center is at 0, 0. Okay, so this is our ellipse. The question is, what's the equation of that ellipse? So can you tell me your A value right now? 5 or 2? 2. A is always going horizontal, right? A is always on your x-axis, so your A value is 2. That's this distance from center to vertex, okay? What's your B value? That's the vertical one, okay? So A is 2, B is 5. So when we write our equation, it's going to be x squared over what? What is a squared then? 4, right. It's x squared over 2 squared plus y squared over what? 25. Y squared over 5 squared, so that's 25. And then it's always equal to 1. So that will be your equation. Okay. I was going to have you try this one on your own, but we're going to run out of time if I do that. So I'm sorry. You're welcome to try it on your own if you want to ignore me right now, but I'm going to keep moving. This one says write the equation of the ellipse. And this one's a little different. It tells you the height of the ellipse and the length of the ellipse, which is basically saying here's your major axis, here's your minor axis, or vice versa. But we know our center is 0, 0. If our height is 18, how far up are we going? 9, right? 9 up and 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and down 9. So those are going to be our vertices. The length is going to be 12. So 6, 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay, and again, you don't have to graph this. If it helps you to graph it, then graph away, but you don't have to, okay? The equation then, what is our A value? What is this? A is going to be 6. What's our B value? B value is going to be the 9, right? That's the vertical, is always the B. So if we're doing x squared over a squared plus y squared over b squared equals 1, then it's going to be x squared over 36 plus y squared over 81 equals 1. Okay, questions on that? Okay. This one says write the equation and is it a function? First of all, is that a function? No, why not? Doesn't pass the vertical line test, right? So the answer here is no. That's just, I want you to see this is not truly a function. But try to come up with the equation for it. So we know it's always this, x squared over something plus y squared over something equals 1. You just have to figure out a squared and b squared. What is a squared right now? 16. This is your a value, right? A is 4. So this is 16, a squared. What's b squared? 4. Okay, your b value is 2. So 2 squared is 4. So the equation of your ellipse will look like that. Questions on that? We got 2 minutes to spare, you guys. We made it.